This is question number 4 from the lesson 11 review for the final exam. I can guarantee this question or something very, very similar will appear on the final exam. It's one of our math department's favorite questions to ask, whether it be a rocket or a ball thrown or kicked or something like that. It's always a very, very similar problem. A toy rocket is shot straight up into the air. The function h of t equaling -16t squared plus 64t plus 7 gives the height in feet of a rocket after t seconds. Round answers to the nearest 2 decimal places as needed. All answers must include appropriate units of measure. And so the first part of 4 is how long does it take for the rocket to reach a maximum height? Write your answer in a complete sentence. Well, in this particular problem, this rocket makes an arc like a parabola, right? So it's an upside down parabola, face down. And so it takes that path in its flight. And so if we want the maximum, we want the vertex of that parabola. And so the formula for that is x equaling -b over 2a. And just to identify our a, b, and c from our original equation, a is -16, that's the coefficient of the first one, b is 64, and c is 7. All right, so if we want to compute this, we want to take negative of b, so that's -64 over 2 times a, and a is also negative. All right, so we'll have -64 over a -32, and that turns out to be a +2. Now, technically, it's not really x equals -b over 2a in this problem because we actually use a t, right? So t stands for time, and 2, let's see, seconds, all right? So the sentence that goes along with this, it takes 2 seconds, and that's our unit of measure, the seconds, to reach maximum height. And you could just write max height is fine for that problem. Now, in turn, part B asks us what is the height? So what is the h of t? What's the height at 2 seconds? So that's the other coordinate of the vertex. So we're going to take that 2 that we just found and plug it back into the equation, just like this. Okay, and I'm just going to take this whole thing here and type it right into my calculator. It's much easier to do that and perfectly fine and acceptable. And so we get a 71. All right, so 71, and that measurement is in feet for height. So 71 feet is the max height of this particular toy rocket. Now, for part C, I'm going to pause my version of the video. It'll probably be seamless for you, and move over to sharing my screen of my calculator, because that is the best way to find how long does it take for the rocket to hit the ground. Because remember, we have our graph. It looks something like this. You know, we just found the maximum height. We want to know now, when is this thing going to hit the ground? And the best way to honestly do that is to find that on our calculators. And so what I will do on my TI calculator when I show that screen is in Y1, I will put -16, I'll actually put x squared. on my calculator, plus 64x plus 7 in y1. In y2, I'm going to put 0, and then I'm going to find that intersection. That's just the easiest way to do this particular problem. So let me pause the recording, although you won't notice the pause, and then I'll move over to another screen. Okay, I am on my TI calculator here, and so I will go to the y equals. And like I said before, I'm going to type in negative 16x squared plus 64x plus 7 in y1, and y2 will be 0 because remember, I'm trying to find out where it lands. The ground is 0 in height. Also, it's considered the x-intercept. Now, if I press graph now, I probably, I won't get really the top of my arc here. So if you want to see the top of the arc, remember, we found the height of the parabola and it was at 71. So I can change my window here to a max of like, y max of like 75, and then I'll see the top of that graph. So then after I do that, I change the top of the graph to be that. And that way I could see the path of my toy rocket. But what I'm really interested in right now is this coordinate right here. All right, so I will press second trace, and I will go down to the intersection. It'll say first curve question, yes. Press enter, second curve, yes, enter. Now my guess, I don't want my guess to be here. See that blinking? I don't want it there. I want it over toward the other one. I don't really care about where it launched from right this second. I want to know when does it land. So around there. So then I'll press enter again, and then it'll tell me the intersection is 4.1 comma 0. All right. And it depends, what did it say? 2 decimal places. Okay, so they wanted 4.11 when we round properly on that. So we want 2 decimal places there. All right, so now I'm going to switch back over to the other share screen. Okay. All right, here we go. So we had said, letter C, how long does it take for the rocket to hit the ground? And so the answer is this. It takes 4.11 seconds to hit the ground. Oops, I spelled that wrong, I'm sorry. Hit the ground. I'm sorry that's squished in there like that, but there we go. All right, so that is easiest. Always the x-intercepts are easiest from the calculator, or you have to do factoring, which sometimes I specifically ask that, but on the word problems, I don't usually. All right, so let's move on to letter D. It says h of 2 equals 71. Write a complete sentence explaining what this means. All right, so the 2 was the t. Okay, the t is inside the parentheses. So that's 2 seconds. So at 2 seconds, and then the 71, the height. So the 71 is outside. The height is 71 feet. Right, so that's really all that it's asking there. Everything's already solved. It just wants you to interpret that coordinate. Next, it says to identify the vertical intercept and write as an ordered pair. Whenever we're doing a vertical intercept, we have a 0 for the x coordinate. In this case, it's the t coordinate. All right, we put 0 in there and we want to figure out what the y coordinate is. So we had negative 16, we'll put 0 in for the t, plus 64 times 0 plus 7, I believe is what it was. And so these first 2 terms, they cancel out to 0, and so we end up with a 7 as our coordinate. right? So we have that, and then interpret its meaning. With T being 0 here, that means when we're first starting to launch this rocket. So at launch, the height of the rocket is 7 feet. So that's exactly what's happening. And that's always what happens at the 0 coordinate. That's probably when you're launching this article, kicking the ball, uh, you know, sometimes it's an arrow problem. It's always the height at which we start this process. All right, it says determine the practical domain of this thing. Okay, so what at what time does this launch start? Well, it starts at 0, okay? And all of these rocket problems, kicking the ball, anything like that will always start at time 0, okay? And when did it end? When did the time end? When did it finally hit the ground? And we found that earlier at 4.11 seconds. So that's the practical domain in interval notation. They wanted inequality notation, and so we'll have to just convert it here from 0 to 4.11. And then this is in seconds. All right, so seconds here. That says, because it says here, include the units. All right. Excuse me. Next, it says determine the practical range. Well, when we started this process, we already knew that the height of the rocket was 7. We found that out earlier. Now, when did the process max out? Okay. Um, actually, no, let's back that up a little bit. Okay. Let's rethink this. My apologies. So it's not when we started the process. What was the lowest point the rocket actually was? Well, when it hit the ground, it was at 0. So that is the lowest point of the rocket, the height of it. And when was the highest? The highest was when it was at its vertex, and that was 71. And so this rocket, the lowest point was 0, the highest point was 71. And those were both in feet. Okay. Now they wanted inequality notation, so I'm going to change this to inequality notation. All right, we're using h of t, that's the height. And so it went from 0 to a height of 71, and we have our feet in there just like that. And so this answers question number 4 from lesson 11 review.